Hey students, so I thought I would show you the way I do it. So in class I kind of showed you how to begin. So let's just say we have some triangle A, B, C. Okay. We know that the area, so we're gonna be working off this angle here. We know that the area is 1/2 A times B times the sine of C. Okay. We're assuming we know these. Okay. Heron's formula assumes you know the three sides and you can get the area. So we know these two things. We don't know the sine of C. To get that, we can use the law of cosines. From the law of cosines, we know that C squared equals A squared. Sorry, my phone really sucks. I'm not even going to try and make it focus. Minus 2AB cosine C. Okay. That's from the law of cosine, so we can solve this for cosine C. We'll just add it over, subtract the C squared, and divide by the 2AB. So we can say that cosine C is A squared minus B squared, A squared plus B squared minus C squared over 2AB. Okay? We can say that. But that gives us the cosine of C. We need the sine of C. So we do so sine C is the square root of 1 minus cosine C. So I'm going to just say sine squared C is 1 minus cosine squared C, which is the 1 minus this thing squared. So 1 minus A plus B squared minus C squared over 4A squared B squared. Like that. So this 1 can be written as 4A squared B squared over 4A squared B squared, right? So that's this. Okay, that's sine squared. So sine C is its square root. Over that thing is just 2AB now. That's sine C, so we can now replace sine C in this formula and get area. We can say area is 1/2 AB sine C. Okay, and we get some cancellation there. And then the 1/2's become a 1/4. And a 4 down here is the same as the square root of 16, so we ultimately can get this. That's as far as I got you in class. Okay. I want to show that this calculation of area is equivalent to Heron's formula. So what I would do is I would start with Heron's formula and try and get that. Okay. And it turns out what we're going to do is so we haven't quite gotten. We started at the beginning with the area formula and the law of cosines, and got to this point, which is potentially the midpoint we want to meet at. So let's start with Heron's formula. The area is the square root of s times s minus a, s minus b, s minus c, where s is 1/2 the perimeter of the triangle. Okay. So what we got to do is replace the s's with this. Okay. So we just replace the first s with this 1/2 of the area. Okay. And then we're in this second grouping here. That s is 1/2 the perimeter minus a. Then we have half the perimeter minus b. And then we have half the perimeter minus c. Okay. Now they each have a half in there, except I can't just factor a half out yet. But what's 1/2 of a minus a? That's negative half a. Right? So I can just write it like this. So this whole thing actually becomes half b, half c, minus half a. Or in other words, it's... So hold on, just for the sake of symmetry or whatever, I'll put that there. That's half of b plus c minus a. Similarly here, this is going to be half of a minus b plus c. And this here is going to be half of a plus b minus c. Now they all have each, now I basically have 8 factors, 4 of which is a half. So this becomes a plus b plus c, b plus c minus a minus b plus c, a plus b minus c over 16. Not surprising that we got a denominator of 16, because this is as far as I got you. Right? We have a square root of the numerator over 16. Here we have the square root of a numerator over 16. Now that numerator is pretty nice looking. It's better looking than mine. So if we can turn mine into that one, we're done. Okay, so this is really meeting in the middle. This is the middle where we want to meet. Sorry about the focus. Okay, so this is where we're going to meet in the middle. It's a pretty nice way of writing this, or we could just say it's the square root of all this over 4, or it's 1/4 of the square root of this product. Right? That's really where I would meet. But anyway, I just want to get my numerator to look like this, and what we derived here. So I'm just going to take this expression and try and see if I can turn it into this. If we can, we're done. We've met in the middle. So I guess what we should say is, let's write this numerator over here. I'm just writing this down here. So 4a squared b squared minus a squared plus b squared plus c squared squared. Alright, I'm going to say it is sufficient to show that this is equivalent to this, that numerator, right? If we can do that, we've met in the middle. So let's just play around with this thing and see if we can get this thing. This is a very factored way of doing it. It's been factored into 4 factors. Here I have 2 terms, but this is a squared, right? That can be written as 2ab squared.
Well, it's the situation where if they,
and that's a difference of squares, so we know how to factor that. That's the first
8 a.m. and they take it at noon.
Plus the second.
Well, if they have a friend who took it earlier,
times the first minus the second.
but it's more likely to have friends inside your own class than.
So that my thing factors like that. Now, we have an a squared, a b squared, and a 2ab, and we kind of have that here. I'm going to factor a minus 1 out of this one, and I'm going to rearrange them. So I have negative, I'm going to put the a squared first in here, then this, then the b squared, and then just leave that off. I factored a minus 1 out of this, so everything's sign changes. So this negative a squared is an a squared. This is a negative 2ab, positive b squared, minus a c squared. Okay. This thing here is a plus b squared. It's a perfect square.
Yeah.
This is a minus b squared.
Why don't you?
And again, we have a difference of squares in each one of those factors now. So this is the first minus plus the second, and the first minus the second. Then over here it'd be the first plus the second, and then the first minus the second. Just factoring it as a difference of squares. So we get minus a plus b plus c, a plus b minus c, a minus b plus c, and a minus b minus c. So it makes sense to send the negative 1 into that one. And we get a plus b plus c times a plus b minus c, and a minus b plus c. And then that changes the sign. If I send it into there, I get basically b plus c minus a. That is a factored form of the thing we had in our numerator. And check it out. They match up. A plus b plus c, a b minus c, a negative b and a c. The one with the negative b is here, and a b plus c minus a. We have all 4 of them in there. We met in the middle. We're done.
Which, that's a good thing.
Okay, so that's the most direct, I think, way of doing it. Thanks for watching.
The other two